All right. All right, so real quick, without a calculator, I'm going to give you some problems. I want you to try to get an answer. It's okay if it's wrong, but I want you to try to get one. Let's go ahead and do 4 cubed, 4 squared, 4 to the first power, 4 to the 0th power, 4 to the negative first, and 4 to the negative second. Positive, negative crap. All right. So just try and get me an answer for all of these. I really think the first 3 you should be able to answer. The last 3 could be hit or miss. I don't know. We'll find out in a second. Yes, but that's not expanded form. That would be the evaluating side. Look at your chart. Expanded form's not my answer, the evaluating. You see what I'm saying? Yeah. Okay. 4 cubed. What does 4 cubed mean? 4 times 4 times 4. Which is what, Hayden? 64. Good. 4 squared? 16, because the 4 times 4 is 16. 4 to the first? 4. 4 to the 0. 1. Why? Huh? Okay, well, that's the rule, yes, but why is that the rule? You don't know? Well, think of it in, if I have a variable, okay, like x to the 0th. What does an exponent actually mean? That 0 tells me x occurs 0 times, but what do I multiply by any exponent that's going to get me back to the original thing? 1. So 4 to the 0th power does not occur, but what can I still multiply that by to still get to the same answer? 1. That is why it's always equal to 1. There is none. It is 1. Because sometimes you'll have those in problems, like when you know how when you have like 2 divided by 2, we automatically know it's 1. Because 2 to the first power over 2 to the first power, we're stacked, so we subtract those exponents. So 1 minus 1 is 0, so 2 to the 0th power is actually that 1. Make sense? All right, Brady, don't answer this for a second, okay? Who has an idea of 4 to the negative first? Let's try Adam first. Okay, 1/4. Michael, what did you get? -4. Brody, what did you put? -4. Hunter, what did you put? -4. It is actually 1/4. Adam is right. Braden's right. 1/4. And I'm going to explain to that in a second, okay? Huh? What would 4 to the negative second power then be? 1/16. We actually can never, ever have negative exponents. Okay? We can never have negative exponents. So to get rid of negative exponents, it actually makes a fraction. So it's 1/4 to the first power. Okay? Which is just 1/4. 4 to the negative second would be 1/4 to the second power. So which is 1/, and what is 4 squared? 16. Okay. Have you guys ever learned scientific notation?
Yeah.
Do you remember how you had, and we're actually doing scientific notation today as well, but you know how you always have like 10 to the negative second power? Like you might have 2.3 times 10 to the negative second power. When you had those negative exponents, didn't we actually have decimals? Yeah. Isn't 1/4 technically a decimal? So those negative exponents actually are those decimals, which are fractions in that sense. All right, so the definition of a to the n negative n power just means when I have a to any negative exponent, it is 1 over a to the positive n power, okay? Everything to be simplified has to have positive exponents. One way I always remember negative exponents, we have to move it to lose it. We can't have them, so we have to move them to lose it. So if we have a negative exponent in the numerator, it moves to the denominator. Now, what if I had something like this? 1 over a to the negative second power, or a to the negative n power. The negative exponent's in the denominator, so it needs to be moved to the numerator to become positive. So we move them to lose them, okay? So what is 10 to the negative third power? Okay. Yep, so it's 1 over 10 to the third power, which 10 to the third power is 1,000. Exactly, so it's 1 over 1,000. We do not want, okay, guys, I do not want decimals. Well, remember, 10 to the third power means I want 3 zeros, so that's why it was 1,000. Okay, all right, 5 to the negative fourth power. What is that in exponent or in fraction form first before we actually do it? 1 over 5 to the fourth. And what is 5 to the fourth? It's 1 over 625. We'll get to that. Oh, no. What is 16 to the negative first power? 1 over 16 to the first, which is 1 over 16. All right, now, we have different bases here, don't we? So can I combine those exponents? No. Okay, but I can do 3 to the second power is what? 9. 2 to the negative third. What do I have to do with a negative exponent? I have to move it to lose it, so I move it to the denominator to become positive. So we're going to get 9 over, and what is 2 cubed? 8. So that is actually 9/8. Because you could have written it as 3 squared is 9 times 1 over 2 cubed. And is it 9 times 1/8? 9/8? Yeah. All right. If A is a non-zero real number, A to the 0th power is going to equal what? 1. 0 to the 0th power has no meaning. It is undefined in that sense. Okay. Yeah. Because 0, anything times 0 is technically 0, so it would never actually equal 1, would it? No. So that's why it's actually undefined in that sense. Okay. All right. So let's look at this. What is A to the 0th power is 1, and 0 to the 0th has no meaning. What's 5 to the 0th? 1. What is 7x to the 0th? 7. Why? Because 7x to the 0th means 7 times x to the 0th. And what's x to the 0th? 1. So 7 times 1 is 7. Huh?
1 unless x is 0.
Right. Okay. All right. 5x squared y to the 5th, z to the negative 5th, all to the 0th power. 1. Now, what if I had this? 3 times 5x squared, y to the 5th, z to the negative 5th, raised to the 0th. What would my answer be in that one? 3. Because this would be 1, and then 1 times 3 would be 3. All right, what do you think negative 9x to the 0th, y to the 5th going to be? Negative 9, y to the 5th, right? Because x to the 0th is 1, and negative 9 times 1 times y to the 5th is that negative 9y to the 5th. Okay. All right. So now we're going to take what you just learned here and apply it to all those exponents that we've learned originally. Yes. Yes. It's weighted. It is weighted. Instead of getting like a 4.0 for an A, you get 4 point something greater. Mm-hmm. I don't know exactly how it's all calculated. It's with points and that kind of stuff. I couldn't tell you 100%, I'll be honest. All right, so let's kind of apply to what we've already known, product of powers. So if I have a to the m power times a to the n power, okay, we have the same base. What do we do with those exponents? We add them. So we get a to the m plus n. So for example, if I have x cubed times x to the negative 4th, what do we get? X to the negative 1st, which gets us then to what? 1 over x. Right? Okay. All right. Quotients. A to the m divided by a to the n. We are stacked, so we subtract. So a to the m minus n. And where do they always, and I said m minus n here, you could do n minus m, but where does the exponent always end up? Where should it always end up? Wherever the higher one is, right? So if I have x to the 5th over x to the 7th, what's easier to subtract? 7 minus 5, right? Which is 2. Where's my larger exponent? Bottom. So it'd be 1 over x to the 2nd. Okay. Another way you can do this, if you subtract the numerator from the denominator. What is 5 minus 7? -2. So it always ends up in the top when you subtract numerator from denominator. Now, how do I get rid of the negative exponent? You move it to the bottom. That's why it always ends up where your larger exponent is, technically. Okay. So stack them, subtract them. Power of a power. So a to the m raised to the n. We're raised high, we multiply. So we have a to the m times n. Okay. So x squared raised to the negative 3rd is what? X to the negative 6th, which is equal to what? 1 over x to the 6th. Well, we got x to the negative 6, and then we got rid of the negative exponent. All right. Power of a product. Okay, so same idea as what we did here. The only difference is we have like 2 products, a times b raised to the m power. If I have multiple things inside my parenthesis, we raise everything, right? Yeah. So what would you get? A to the m power, you mean? B to the m power, right? But again, if there's exponents, you raise them high, you multiply. So if I have this problem like 2x to the 4th raised to the negative 3rd power, what would we get there? 2 to the negative 3rd, x to the 12. So what do we have to do with those? Put them on bottom. So 1 over, what's 2 cubed? 8, x to the positive 12. Okay. What? I don't know how to say blue, probably. All right, quotient. A over B to the m power. Same idea. We're raised high, so we multiply, so you raise it to everything. So it'd be a to the m over b to the m. So an example, let's do 3 over x to the 5th raised to the negative 2nd power. So what would that be? 3 to the negative 2nd over x to the negative 10. Now, what do I have to do? Flip, right? So the 3 is going to go to the bottom, and what's 3 squared? 9. And the x to the negative 10th is going to go to the, so x 10 over 9. Oh my gosh. Okay. Now, one thing I'm going to tell you guys, anytime I have them like stacked, like this one or here, I tend to, with subtracting, do you guys like subtracting negative numbers? No, I would tend to always get rid of negative numbers when you're subtracting, okay? Just so that if you can avoid subtracting negatives, the better off you are, okay? Can you add negatives? Yeah, so if it's like the first one here, a lot of times I leave the negatives, but if I know I have to subtract something, I get rid of the negatives, okay? I don't know. So looking at A, we have 5 to what power? This is 5 to the 1st over 5 to the negative 3rd. We're stacked, so technically we would, subtract. However, do you guys like negatives again? No, so let's get rid of the negative. How would I move this 5 to the negative 3rd to the top? I'd flip it. So I would have 5 to the 1st times 5 to the 3rd. Now, we're multiplying. What do you do with those exponents? Add. So I'm keep the base, which is 5 to the 4th power. And it's 625. Huh? I didn't put a negative. Yeah. Where did I put a negative in? Okay, enough there. Well, you should have the notes.
I do.
Funny. Yeah. You didn't write them all down, let's be honest. And you didn't write them all down. And you don't write them all down. Just be honest, you don't write everything down anyways.
I wrote down majority of it. I didn't write down everything.
Okay, there you go. You didn't write down everything. Okay. Well, then do you understand why sometimes things get marked wrong when I can't read them? Yeah, okay. All right, B, we're raised high, we multiply. So we're going to get B to the positive 3rd. Why? Because a negative 1 times a negative 3 is positive. We have a positive exponent, so we're done. Okay. C, 3x to the negative 1st squared. So we're going to raise everything, and we're raised high. What do you do with the exponents? Multiply. So we're going to get 3 to what power? 2nd. X to the negative 2nd. Put it away. 3 squared. No, I'm not putting the written notes up online. 3 squared. 9. What do I have to do with x to the negative 2nd? Put it on the bottom. So we get 9 over x squared. Now we're going to apply and put multiple things in all of these. Okay. Now, if I were you, I would try to simplify things first before I raise anything. Okay. Or if I'm stacked, I try to get rid of negative things before I simplify things. So if this was me, I would try to simplify everything on the inside first. Okay. And what are we doing on the inside? We're multiplying. So what do you do with those exponents? You add. But what do I do with those big coefficients out in front? I multiply them. So I will do 2 times 2, which is what? 4. All right, let's do the u's. We have u to the 3rd, and we have u to the negative 2nd. So what is 3 plus negative 2? 1. Then let's do the v's. We have v to the 3rd, v to the negative 1st, and v to what power? The 1st. So does it matter the order you add things in? It's just going to be v to the third. Why? Because 1 plus -1 is 0. That cancels out. And 0 plus 3 is 3. And then raised to the -3rd power. So now we're raised high. We multiply. But we have to make sure we raise everything. So this will be 4 to the -3rd. U to the -3rd. V to the -9th. And now what do I have to do with every single one of these? Move it to the denominator. Why? To become positive. So what is 4 cubed? 64. So 1 over 64. U to the 3rd. V to the 9th. And that would be your final answer. Okay. All right. Looking at C. 2x to the 4th times x to the 4th raised to the -3rd. Now, inside the parentheses, is there anything I can do? No, so I do have to get rid of that parenthesis first. So we're raised high, we multiply. So we have 2x to the 4th times x to the -12. Okay. Now, we are multiplying. What do you do with those exponents? You add. So I'm going to get 2x to the -8. Now, here's the most common thing people do. Is that 2 going to stay or move? It is going to stay. Why? It's not a negative exponent. It's exponent's 1, right? But x to the -8 is going to move to the bottom. So we get 2 over x to the 8. All right. Looking at B here. Stop or leave. Okay. Looking at here, what do you guys notice in B right off the bat? Okay. There's a 0. So what can I do to that 0? I can get rid of it, can't I? So I'm just rewriting this for a second. So the speed of the 0 is 1, so it just cancels out automatically, right? Now, is there anything else I can simplify right off the bat? The 4 and the 2, right? What does 4 over 2 simplify to? 2 over 1. Is everyone okay with that? Mm-hmm. Now, we're stacked, so technically we would do what? Subtract. But do you like to subtract negatives? No. So could I move that a to the bottom and make that 2 over, move this a down, a to the 4th. Then I have a squared. I have 3. I have a to the 4th. And I have b to the 3rd. Huh? You okay? All right. Now, 2 and 3, can I simplify the 2 and the 3? No, so we'll leave it as 2 over 3. Now, we're all multiplying. Can I combine all these a's on the bottom? A to the 8, 9, 10. Yep, a to the 10th, because we add those exponents. And then what am I left with? B to the 3rd. And that's your final answer. Yeah. Simplify the 4 and the 2? Yeah. Yes, if that was a positive 4, I could cross out these 2 a's. Yep, exactly. So that's what I'm going to do in the next one here. All right, so I'm going to rewrite this just so it's bigger here. So we have 4x to the -3rd, y to the 4th, over 4x squared y4 times 3x -2 y4. Okay? So now, do I see anything on top and bottom that is the exact same that I can cross out? I can cross out the 4's because 4 divided by 4 is 1. Y to the 4th, why? The same, because if I would subtract those exponents, what's 4 minus 4? 0, and anything to the 0th power is 1. Okay? Yes. I will in a second. Yep. So now, do we want to deal with now on the bottom here, we are multiplying. So what could I do with those exponents? Add. And is it okay to add negatives? Yeah. What's 2 plus -2? 0. So x to the 0th is 1. So wouldn't those 2 cancel out as well? Yeah. So now we have x to the -3rd. So where does that have to go? to the bottom. So I move that to the bottom. We have 3, so where would 3 stay? On the bottom in the front. I always put the numbers in front, and then what else do we have? 1 and 4. Now, I don't have anything on top, so what number do I put? 1. And there you go. That would be your final answer. You just move it to the bottom. If the negative's on bottom, you move it to the top. So like here, I could have moved the x squared on top here, that negative 1 on top, and then couldn't I just cross out these? That's why I could cross those 2 x's out. Okay. So there's multiple ways you could have done it. You could have gotten rid of all the negatives first and then gone from there if you wanted to. Okay. Any questions on 7.9? All right, let's do 7.10. Okay. Thank you, Adam.
Is there a 7.711? No, like, is there in the book?
No.
Oh, is it?
All right. Scientific notation it's a way that we can work with numbers, an easier way to work with numbers. Okay, and you guys can't see that. Let me zoom that back up. Thanks, Andrew. All right. Scientific notation is in the form of A times B, or excuse me, let me rewrite that. 10 to the B power. A times 10 to the B power. Where A is a number between 1 and 10. Now, it can equal 1, but cannot equal 10. So on the left of a decimal point, it can only have 1 unit. It has to be in the ones unit. Okay? And then B is just an integer. So positive, negative numbers, does that have decimals or fractions or anything like that? No. Okay. So as I look at the number of 118 million, okay, I want to write this in scientific notation because that's kind of a big number, right? So I want to put a decimal place in between 2 numbers that would give me a number between 1 and 10, right? So if I look at 118, okay, because the zeros at the end is not going to matter for us. So I'm not going to put my decimal point between the 1 and the 8 here because I would have 11.8. And is 11 between 1 and 10? No. If I put it between the 1 and the 1, is 1.18 between the numbers 1 and 10? Yeah. And then we'll have times 10. Now, anytime your number is greater than 1, you're going to have a positive exponent, right? And think about that. We're going to have, when I had like 4 to the second power, I got 16. 4 to the third power is what? 64. Those numbers, if you have positive exponents, don't they get bigger and bigger and bigger? Yeah. So how many times did I actually move my decimal place to get to be in between 1 and 1? 8 times. So that would be to the positive 8. Okay. So we moved to the left 8 units. Right? We moved it to the left 8 units. Okay? Because think about this. When you had an exponent of 8, how many zeros did you technically need? 8, right? But I have 2 units past that, so it really 6 zeros and 2 units. Yeah. No, it's supposed to be 6. Yeah. I told you I was on a roll. All right. Now, looking at here, 4,709,000,000. Okay. We have the number of 4709. I don't have to list all the zeros there, but I do have to list this because we have a unit of 9. Now, where would my decimal place go? In between the 4 and the 7, because now 4.7 is in between 1 and 10, right? Yeah. Times 10 to the, how many units did we move? And again, we moved it left, because this is a large number. We moved it how many times? 9. Why? We had 3 zeros, and then the 709. So isn't that 369? Yeah. So 9 units. All right. Yes. My decimal point's at the end, and I need to move it all the way between the 4 and the 7s. How many units did I move it? 9. Okay. Now, this number, these last two are less than 1, right? What kind of exponents give you a number less than 1? Negative, right? Because remember, when we said 4 to the negative first, that was what? 1/4. Isn't 1/4 technically 0.25? It's a decimal, right? So now we move our decimal to the right. Now, we have the number of 152, right? Where would my decimal place go here? In between the 1 and the 5. So we're going to have 10, but it's going to be a negative exponent now. And how many units? 4. So we moved it right 4 units. All right. Now, looking at the next one, we have 25 as my number. So where would my decimal place go? Between the 2 and 5. Now, are we going to have a positive or negative? Negative, because we're moving to the right because it's a decimal. And then how many times do I move this? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So negative 13. There you go. All right, go ahead and do A and B on your own. You can as soon as you go home. Huh? Do A and B. So my number in A, 5, 8, 1, 2. So where would my decimal place go? In between the 5 and the 8. Am I going to have a positive or negative exponent? Positive. And how many times I move it? So 10 to the 10th. Okay. So my number in B is 72. Where does my decimal place go? Positive or negative exponent? Negative. And what do we get? 7, 3, 6, 7. Yep. Bless you. You're welcome. All right. Write each number in standard form. So now we're in scientific and we need to make it into a number, right? If we have a positive exponent, which direction am I going to move it? To the right. Why? Because we need a bigger number, right? So because this is positive, we're going to move it to the right because we need a large number, right? So if I'm at 4.95, I'm going to move it to the right 8 times. So 1, 2, and how many? I need 6 more. So how many zeros am I going to add? 6, 1, 2, 3, 4, 5, and 6. So we have 4, 9, 5, and 6 zeros. So 495 million. All right, negative. So since this is negative, we need a small number, right? So we need to move it to the left. That's left, okay? So we're gonna go 1, 2, 3, 4, 5. So how many zeros do I need? 4. And I have to show my decimal point here. So 0.00000763. Example 3, is the number in scientific notation? If not, write it. So is 23.1 times 10 to the 3rd in scientific notation? No. Why not? because that's greater than 10. 23.1 is greater than 10, right? So now I'm going to go ahead and write this here for a second. 0.1 times 10 to the third. Now, real quick, if I look at 23.1, am I going to have a positive or negative exponent? I'm going to have a positive. So I'm going to add to that exponent. How many units, where does this decimal actually have to be? Between the 2 and the 3. So how many times did I actually have to move it? 1. So I'm just going to add 1 to that 3. And what's 3 plus 1? 4. So it's 2.31 times 10 to the 4th power. That's one way to do it. Another way is you could write this as a real number, right, in standard form, and then convert it to scientific if you wanted to. All right, what about B? Is 3.12 times 10 to the negative second? Yes. Okay. What about 0.07 or 0.7 times 10 to the negative fourth? No. Because 0.7 is what? Less than 1, right? So real quick, I rewrite this for a second. 0.7, is that going to be a positive or negative exponent? It's going to be negative, so I'm going to subtract. How many times do I have to move my decimal over? Once. So it's going to be 7 times 10 to the negative 5th power. And there you go. Simplify, write your answers in scientific notation. Now, this is exactly what we did just a minute ago in 7.9. The only difference, instead of having x's, they're just 10s to the power of 10. So if I gave you 3.2 over 2.0, could you guys actually simplify that and divide it? Yeah, what is 3.2 divided by 2? 1.6, right? 1.6. 32 divided by 2 is 16. So wouldn't that be 1.6? Now, the only thing with this is because in scientific notation, is it okay to have negative exponents? So when we're stacked, we are going to subtract our exponents. But when we subtract, you always go numerator minus the denominator. Our base is going to stay the same of 10, but now what's 7 minus 4? 3. Is this in scientific notation? Yes. So you're done. All right. Now, this is all multiplication, right? So does it matter the order we multiply them in? No. So isn't this the same thing as 2.5 times 6 times 10 to the third times 10 to the second? Is that all the same thing? Yeah. What is 2.6 times 6? Yeah. Yeah, thank you. 2.5 times 6 is? Isn't it just 15? Yeah, because it was 15.0, right? Okay. Times, now what do I do with the exponents here? Add them. So I get times 10 to the, no, 5th. Right? 2 plus 3 is 5. Why did that say 10, not 100?
Because scientific notation. That's why.
Well, but because when you multiply, don't you always keep the base? Yeah. When we add the exponents, you always keep the base. That's why. All right. Are we in scientific notation? No. So where does the decimal go? Between. Now, 15. Is that going to have a positive or negative exponent? Positive. So we have to add. How many times did I move it? Once. So times 10 to the 6th power. Sarah, were you actually ahead of me when you said 10 to the 6th or no?
I was, but I also did the math wrong.
Okay. All right. Any questions so far with that? Pretty easy. All right. Looking at this one, okay, we have the distance from the sun to Mercury is approximately 6 times 10 to the 8th power kilometers. The distance from the sun to Pluto is approximately 5.9 times 10 to the 9th. Find the ratio of the first distance to the second. What's a ratio?
Sorry, I'm not going to say when
Not necessarily. The bigger number does not necessarily have to be in the front.
There's 2 dots.
Okay, 2 dots. It's just a comparison. And remember, with those comparisons, we can write it 2 ways. We can either write it as with the 2 dots. We could write it with what? The word 2, or we could write it as a fraction of A over B, right? Now, it tells us what we want to compare. It wants to compare the first distance to the second distance. What's my first distance? 6 times 10 to the 8th over, and I'm going to do a fraction. And what's my second? 5.9 times 10 to the 9th.
Well, you can do it.
Right, but we need to simplify this, don't we? Yeah. It's harder to see it if you put the 2 dots, wouldn't it? Isn't it easier when you see fractions, you know you should simplify, right? So if I gave you 6 over 5.9, can you simplify that for me? And I don't know it off the top of my head, so I'm going to use a calculator as well. And I'm going to go ahead and I'm going to round it. So let's do 102. Times, what do we do with the exponents? We are stacked, so we subtract. And what do we always subtract in these ones? Numerator minus the denominator. So 8 minus 1 is 8 minus 9 is negative 9. I said that completely wrong. Is this in scientific notation? Yes. So you're done. Okay. Any questions with that so far? Okay. Another way you can look at this, I want to show you one other thing here. If I break it up like this, 6 to 5.9 times, we got 10 to the negative first, isn't that the same thing as 1 over 10 to the first power? And what is 6 over 5.9 times 1 over 10 to the first? 6 over 5.9. So that's my actual 59, sorry. That is my actual true ratio of those 2 distances, 6 over 59. Okay. All right, any questions with that so far? No. All right, I'll go ahead and stop right now and just give you guys a little break here. Homework, I'm going to change just a tab for you. Not much, okay? So your assignment, okay, is page 333, 6 through 57 multiples of 3. And page 339, we are going to do 3 through, hold on. I say 3 through 12, multiples of 3. And I want to do 27 through 31. So that's it changed a little bit. So even guys on Canvas, as you're looking at